The National Electrical Code specifies minimum distances for electrical equipment from water to prevent electrical shock hazards. For an air conditioner compressor, a minimum distance of 10 feet, which is 3.5 meters from the water's edge, is required. For other electrically powered equipment that is not part of the pool equipment, a minimum distance of 5 feet, or 1.52 meters from the water's edge is mandated. However, there are exceptions to these rules. Firstly, equipment that is specifically designed and labeled for outdoor use in wet locations is exempt from these distance requirements. Secondly, equipment that is permanently connected to a ground fault circuit interrupter, or GFCI, is also exempt. Thirdly, equipment that is enclosed in a weather-resistant housing may also be exempt. It's crucial to remember that these are minimum distances specified by the National Electrical Code, and local building codes may have stricter requirements. Always check with the local authority having jurisdiction to ensure compliance with all applicable codes and regulations. Understanding the reasoning behind these distances is vital for safety. Water is an excellent conductor of electricity, and the presence of water significantly increases the risk of electrical shock. The NEC establishes these minimum distances to create a buffer zone, minimizing the likelihood of electrical current reaching a person in or near the water. Ground fault circuit interrupters, or GFCIs, are a crucial safety device designed to protect people from electrical shock. They work by monitoring the current flowing in a circuit. If the GFCI detects a difference in current between the outgoing and returning conductors, it indicates that some of the current is leaking to ground, potentially through a person. When this happens, the GFCI quickly trips the circuit, cutting off the power and preventing a dangerous shock. The GFCI protection provides an additional layer of safety when electrical equipment is used near water. Equipment designed and labeled for outdoor use in wet locations is constructed with materials and features that make it resistant to moisture and corrosion. These features include waterproof enclosures, sealed components, and corrosion-resistant coatings. This type of equipment is built to withstand exposure to rain, humidity, and other wet conditions without posing an electrical hazard. The weather-resistant housing also provides a barrier against moisture and corrosion, protecting the electrical components inside. This type of housing is typically made of durable materials that can withstand exposure to the elements. When installing electrical equipment near water, it is essential to follow all applicable codes and regulations. This includes obtaining the necessary permits, using the correct wiring methods, and ensuring that all equipment is properly grounded. Proper grounding provides a low resistance path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and prevent electrical shock. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years to reflect the latest advances in technology and safety practices. The NEC is not a law itself, but it is widely adopted by state and local jurisdictions. Compliance with the NEC is essential for ensuring the safety of electrical installations. When working with electricity, always take precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Energize the circuit before working on any electrical equipment. Use a voltage tester to verify that the circuit is de-energized. If you are not comfortable working with electricity, hire a qualified electrician. When selecting electrical equipment for use near water, choose equipment that is specifically designed and labeled for outdoor use in wet locations. This type of equipment is built to withstand exposure to moisture and corrosion. Ensure that all electrical equipment is properly grounded. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and prevent electrical shock. Install ground fault circuit interrupters, or GFCIs, to protect people from electrical shock. GFCIs are required in many locations, including bathrooms, kitchens, and outdoor areas. Inspect electrical equipment regularly for signs of damage or wear. Replace any damaged or worn equipment immediately. Never overload electrical circuits. Overloading a circuit can cause the wires to overheat and start a fire. Be aware of the hazards of electricity and take precautions to protect yourself from electrical shock. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or other expert before undertaking any electrical work. It is also important to understand the difference between bonding and grounding. Grounding connects electrical equipment to the earth, providing a path for fault current to flow back to the source. Bonding connects different metal parts of an electrical system together, creating a low impedance path for fault current to flow. Both grounding and bonding are essential for electrical safety. The size of the grounding conductor is also important. The grounding conductor must be large enough to safely carry the maximum fault current that could flow in the event of a short circuit. The size of the grounding conductor is typically determined by the size of the circuit conductors. It is also crucial to ensure proper overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overload and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Regular inspection and maintenance of electrical equipment are vital. This includes checking for loose connections, damaged wiring, and corrosion. Any problems should be corrected immediately to prevent potential hazards. When working with underground wiring, it is essential to use caution and avoid digging near buried cables. Contact the local utility company before digging to locate any underground utilities. Never attempt to repair damaged underground wiring yourself. Contact a qualified electrician to perform the repairs. Surge protection is also important, especially for sensitive electronic equipment. Surge suppressors protect equipment from voltage spikes that can damage or destroy electronic components. These spikes can be caused by lightning strikes, power outages, or other electrical disturbances. In addition to the NEC, other standards and regulations may apply to electrical installations. These may include state and local building codes, as well as industry standards. It is important to be familiar with all applicable requirements before undertaking any electrical work. The use of arc fault circuit interrupters, or ASICs, is also becoming increasingly common. ASICs are designed to detect arc faults, which are a common cause of electrical fires. Arc faults occur when electricity jumps between two conductors, creating a spark. ASICs strip the circuit when they detect an arc fault, preventing a fire from starting. The location of electrical outlets is also important, especially in wet areas. Outlets should be located at least 12 inches above the floor in bathrooms and kitchens to prevent them from getting wet. Outlets near sinks and other water sources should be GFCI protected. The use of extension cords should be limited, as they can be a fire hazard. If an extension cord is necessary, it should be heavy duty and properly rated for the intended use. Never run extension cords under rugs or carpets, as this can trap heat and create a fire hazard. When replacing electrical devices, such as switches and outlets, use only devices that are UL listed or otherwise approved for use in the United States. These devices have been tested and certified to meet safety standards. The proper use of electrical tape is also important. Electrical tape should be used to insulate splices and connections. It should be applied tightly and in multiple layers to provide adequate insulation. Never use duct tape or other types of tape for electrical insulation. The installation of smoke detectors is also crucial for fire safety. Smoke detectors should be installed on every level of the home and in every bedroom. Test smoke detectors regularly to ensure that they are working properly. Change the batteries in smoke detectors at least once a year. Carbon monoxide detectors are also important, especially in homes with fuel-burning appliances. Carbon monoxide is a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed on every level of the home and near sleeping areas. Test carbon monoxide detectors regularly to ensure that they are working properly. If you smell gas, evacuate the building immediately and call the gas company from a safe location. Do not turn on any lights or appliances, as this could ignite the gas. If you experience an electrical shock, seek medical attention immediately. Electrical shock can cause serious injuries, including burns, heart problems, and nerve damage. Even if you feel fine after an electrical shock, it is important to see a doctor to rule out any underlying problems. Remember, electricity is a powerful force that can be dangerous if not handled properly. By following these safety tips, you can protect yourself and your family from electrical hazards. Always prioritize safety when working with electricity.